Alright, so here are the lab preparations for the conservation of matter lab. So the question we're going to answer today is, how can we prove the law of conservation of matter? So this goes in your question section of your handout. How can we prove the law of conservation of matter? So if you remember, a French chemist by the name of Antoine Lavoisier established the law of conservation of matter based on his experiments. He was the first one to recognize that the total mass of the products equaled the total mass of the reactants, that whatever went into the reaction also had to come out, mass-wise. So we are going to be performing a double replacement reaction of water and something that's called sodium bicarbonate. Now, sodium bicarbonate is also known as Alka-Seltzer. Alka-Seltzer. There you go. Okay, and it's used to neutralize the acid that's in your upset stomach, but you don't just swallow the tablet, you dissolve it in water, and a reaction takes place, and then you drink it, and that neutralizes the acid. So the reaction that takes place is you have water plus your sodium bicarbonate, which is your Alka-Seltzer, and produces something called carbonic acid and sodium hydroxide. And it's the sodium hydroxide that actually neutralizes the acid in your stomach. Sodium hydroxide is something that's called a base, and a base and acid neutralize each other. So, carbonic acid, however, H2CO3 is carbonic acid, automatically decomposes as soon as it is created. And it decomposes into carbon dioxide gas, CO2, and liquid water. So, really, the reaction that takes place is water plus your Alka-Seltzer. Instead of carbonic acid, it really creates water and carbon dioxide, and then sodium hydroxide is left over. So this is our actual reaction. Now, the carbon dioxide is a gas, and so we need to be able to trap the carbon dioxide gas in order to verify the law of conservation of matter. And so here's my carbon dioxide. It's like behind bars. That's my attempt at drawing. All right, so we got to be able to trap this carbon dioxide gas in some way. We're going to trap it using a balloon that's been pulled over an Erlenmeyer flask, and the balloon will inflate with the carbon dioxide. So hypothesis, you need to make a hypothesis. The hypothesis, the total mass of the reactants in our reaction, and remember our reactants is our water and our sodium bicarbonate. What will it be compared to the mass of our products, water, carbon dioxide, and sodium hydroxide? Is it going to be greater than the total mass of the products? Is it going to be equal to the total mass of the products? Or is it going to be less than the total mass of our products? So you need to write one of these three things into your hypothesis. The total mass of the reactants is going to be what compared to the total mass of your products? So the actual experiment, you're going to take about 50 milliliters of water and put it into an Erlenmeyer flask. The 50 is the very last little mark. Doesn't have to be perfect, but just about 50 milliliters. You're going to take a balloon and stretch it out like you sometimes do before you blow it up. That gets it all prepared, ready to be blown up. And then you're going to take your Alka-Seltzer tablet. Let's take it out of the thing. You're going to take the tablet and you're going to start breaking it up into smaller pieces. You probably want like fourths or smaller. Okay? And now, one of you needs to hold open the balloon as best as you can, and the other one, pop those pieces in. And the key is you want the pieces to not be trapped here. You need them to fall all the way down into the main part of the balloon. Okay? So that's why you need to make sure they're small enough. Now, get as much of the tablet as you can. You don't have to get all of it. Okay? Once you've taken that, you're going to take your balloon and very carefully over the lip of the Erlenmeyer flask, you're going to stretch it. Okay? So it's going to be stretched over the top. Now make sure the Alka-Seltzer does not fall into the water yet. That's why it should be in this part of the balloon. But it needs to be all the way around, nice and secure around the lip of the Erlenmeyer flask. Now, if yours tears like mine just did, come tell me. I'll get you another balloon and you can start over. Okay? So no tearing. Now, once that's over the top, you're going to find the measurement of the of the balloon and the Erlenmeyer flask. I'm trying to do another one here. Of the balloon and the Erlenmeyer flask. Okay, so find that mass, and then pick up the balloon, let the Alka-Seltzer tablets fall into the water, and watch the reaction occur. And you're going to take, after the reaction has completely occurred, you can swirl it very gently to make sure you've reacted all of it. You'll be seeing bubbles and fizzing. You'll know that a reaction is taking place. Once it's done, take this, do not take the balloon off, take it and find the mass of this, everything all together, and record that in your data section. When you clean up, you can just take off the balloon, record what you notice. This can just go down the drain with lots of water. Rinse this out, dry it out as best as you can, and return it to the station that you got it from. And then you have some questions to answer, and then I want a short paragraph just kind of concluding what happened, what did you see, what did you think. And that is the lab, and I'll see you tomorrow. Bye.